Hey everybody, welcome to the video on dividing rational expressions. Now this is a straightforward, we only have two problems here, so this is a very kind of straightforward concept because it is very similar to the concept we just did in multiplying rational expressions because just the way in which we multiply and divide fractions. So for example, if I had 3/4 times 2/3, all right, we would multiply across just like we do with our regular fractions, and we would get 6/12 or equal to 1/2. Now, as we learned, we can cross simplify these, which would make it possibly a little bit easier. Like 3 divided by 3 is 1, and this becomes 2, and this becomes 1, and I eventually get the same answer as 1/2. Similar thing here. If I were to have, let's say, 3/4 divided by let's say, for example, 9/16. All right. Now, in this case, remember, when we divide fractions, we multiply by the reciprocal. So we leave the first one the same, and then we multiply by the reciprocal of the same fraction. Now, I see these, and I'm like, man, I don't want to sit here and do 3 times 16 and 4 times 9, even though it's 48/36. But instead, I'm going to simplify first before I multiply. So for example, I look at my guy across the way, and I see that the greatest common factor of those is 3. So I change this to a 1 and this to a 3. And then I also notice from across the way that the greatest common factor of these is 4. So this becomes 1 and this becomes 4. So my end answer would eventually be 4/3. Now, the reason why I'm showing you this is just the properties of basic multiplying and dividing fractions, but also the similarity between multiplying and dividing. And again, this is why I only have two example problems, because in my last video on multiplying rational expressions, I worked through 4. So the only difference between dividing and multiplying is that before we start the problem, we have to multiply by the reciprocal. So let's test that theory here. So for example, I notice that it is division, and so I just have to rewrite the equation in the form of multiplication. So let me do that real quick. Multiply by the reciprocal. Notice how the first expression, the first rational expression, stays the exact same. And then I change the sign to multiplication, and then I just write the reciprocal of this rational expression, which would be the numerator and denominator switching. So we have n squared plus 10n plus 21. Alright, so now I am just back to the same exact problems I just did in the previous video on multiplying rational expressions. So now I got to go through my steps of simplifying these. So n minus 7, you're going to stay the exact same. I'm going to go up here and I'm going to see, alright, 2 factors of negative 56 and when added together equals negative 1. That case would be negative 8 and 7. So, I'm using my wrong variable again. That would be m plus 7 n minus 8. Alright, and then I look here and I see, alright, I can factor out a 7. Maybe you guys, or sorry, a 6. And some of you guys might see where I'm headed with that, but just give me a second. I'll pretend that I do not see that. So that would be 42 divided by 6 is 7. And then I divide the 6n divided by 6. Again, you notice that if you distribute that 6, you should end up with the exact same expression, where you're just writing it in a different way. We're simplifying it so that we are able to cross things out. And then also, we need to find 2 factors of 21 that would add together equal 10. In this case, that would be 7 and 3. So we have, I about did it again, n plus 7, n plus 3. All right. So now this is very important. This is a concept we discussed in the last video, in that we have 7 minus n. Okay, that looks a lot like that, but they're not the same. And so what I need to do is I need to factor out a negative 1. Now, just because a 6 is in front, it's not going to really change anything. I'm just going to attach a negative sign to that, and that is going to switch around the terms. So if you want to know how that works, the previous video discusses that, how if I factor out a negative 1, that just changes the signs, and I write it so that the variable is in front. Then again, we write this. So let's see here, n minus 8, and we have n plus 7, n plus 3. Okay, now we're going to cross everything out. My favorite part, we have n minus 7, n minus 7, n plus 7, n plus 7. And sorry, unfortunately, this n minus 8 and n plus 3, we can't do anything about those. Now, please do not forget about this minus 6 in front. Okay, some people get all happy because they found the answer, but then they forget about that negative 6. So we're going to have n minus 8. And then this guy comes across and multiplies whoever is here. So that'd be negative 6 times n plus 3. I can keep the parentheses here. In this case, I would have to keep the parentheses, but you don't really have to write the parentheses on top if you don't want to. If it makes you feel fine, I'm not going to be against anything. You could write it like this or without the parentheses, with the parentheses or without. So that is my end answer with that one. Okay, now take a moment to see if you can solve this problem on your own, and then you can watch me work it here in just a second. Our first step for this top part is to divide by 2. All right, let's hold on. I guess I'm jumping to conclusions here. We see that it is a division problem, which means I have to multiply by the reciprocal before I start. So I'm going to multiply by the reciprocal. Again, the reciprocal is just these guys flipped, so 2x squared minus 2x minus 4 over 4x squared minus 6x. Now I am just at the same problem I had in our last video, which is multiplying rational expressions. So what I'm going to do is I'm going to factor out a 2. That is the greatest common factor of these numbers, so that leaves me with 2x minus 3. And then the greatest common factor of these is 4, so that would be 4x plus 1 times, and then on this one we notice, before I even start this, and I'm going to kind of erase some of my work to show you this, is that I have to remember that if I can factor something out, I have to factor something out, especially in this case. So we notice right off the bat that I can factor out a 2. So when I do that, I'm left with x squared minus x minus 2 inside the parentheses. I factor this, so I need to find 2 factors of negative 2 that would equal negative 1. And so we have 2, and in this case, x minus 2, x plus 1 is my 2 factors there. So if you forgot to factor out the 2, all right, and you just factored this as is, you would notice that we would forget this too, because yes, we would have this as our factored expression, or our factors of this expression, but we'd be missing this 2 if we went to FOIL it out. And so it's imperative that you remember that to look for that common factor before you, or the greatest common factor before you factor the whole entire expression. All right, so I'm going to put that right here, so that's 2 over x minus 2 x plus 1. And then on the bottom here, I notice that I can factor out a 2x out of the bottom. All right, so we have 2x, and then that would be 2x minus 3. Okay, now these are very similar, but they are not the same. So don't cross off 4x minus 6 and 4x squared minus 6x because they are different in that you had to factor out an x beforehand. But now that we have done that, let's factor some stuff out. We have, or we can cross some stuff out. 2x minus 3, 2x minus 3, x plus 1, x plus 1. Now for the sake of just keeping things simple for us, I am just going to multiply across, multiply all the leftovers across, and so I get 2 times 2 is 4, x minus 2 over 4 times 2x, which is 8x. Now I'm not quite done with the problem because I notice right here that I can simplify these numbers right here. 4/8 is the same as 1/2. And so you can keep the 1 up there. I'll keep it up there just so you guys can see the transition here. So 4/8 is the same as 1/2. And so this is the ultimate simplified expression. So again, I hope this video helps. Please come see me if you have any continued questions, and we will start this up very soon. Thank you and have a good day.